All right, the last video, for some reason, when I went to pause it, it ended it. So we're going to be 2 videos long. So the first one will be answering the question 1 that we did, and now we're going to move on to the next questions. All right, so for this one, we're going to be answering number 2. So for here, it's a little bit different than maybe what we were doing, but you need to identify that these lines here, they form that X that some of you guys are talking about, and it forms vertical angles. So our vertical angles in this case are going to be this entire angle here with this entire angle. So that means they're equal. Well, the way for us to identify this entire angle in here is we would have to add these two together, because if you have two separate angles, and this is 5 degrees and this is 8 degrees, or I guess I should make it 50 degrees and 130 degrees, we know that we can add them together to get a total of 180. So it's the exact same thing that we need to do here. So that means this entire angle that I'm coloring in here is equal to 3x plus 18 plus 2x minus 3, which is going to be 5x plus 15. And since these angles are vertical angles, I know that they're equal, so I can say 5x plus 15 is equal to 130. I can then subtract over the 15 from both sides and get that 5x is equal to 115. Divide each side by 5 to solve for x, and x is then equal to 23 degrees. All right, let's move on to the next question. All right, so the next one now, we look here, we have this angle and this angle, and these are both on the inside of our two parallel lines, and they're on the same side of the transversal, so these are same side interior angles. And same side interior angles are supplementary, which means they add to 180 degrees. So 5x plus 40 plus 3x plus 20 is then equal to 180 degrees. Now we solve this. 5x plus 3x gives me 8x. 40 plus 20 is 60. So we will subtract 60 from both sides. So 8x is then equal to 120. Divide each side by 8. X is then equal to 15. So we get x is then equal to 15 degrees. Oh, shoot. It says describe the relationship. The last problem, I didn't write it down, but I said that they're vertical angles. Make sure in your test that you're writing same side interior angles. All right. So if you do not write and describe the relationship between the angles in words, now I said it out loud to you, so you're hearing it, but make sure in the test that you write it down. So this will be worth points, identifying it. Setting up your equation will be worth points, and then solving for x will be worth points as well. All right, so make sure that you are writing it out. So describe the relationship and then solve for x. All right, so for this one, same thing. First thing you have to do is identify what relationship do we have with these angles. So in both, remember, we're always comparing one intersection to the other. This is our bottom right, and so is this one. They're in the exact same position, which then means that they are corresponding angles. So you must first describe the relationship, so corresponding angles. And now we know corresponding angles are equal. So we can then say 2x minus 6 is equal to 68. And now we can add 6 to both sides. So 2x is then equal to 74. Divide each side by 2. And we get x is then equal to 37 degrees. All right, so make sure you're describing the relationship, setting up your equation, and then solving. And remember, this was for number 4. I didn't label the last one, but that was for number 4. All right, same thing. We need to describe the relationship, so we need to identify it first so we know what we can do. So we're comparing this angle with this angle. They're both on the outside, the exterior of our two parallel lines, so we know it's going to be something with exterior, and they're on opposite sides of the transversal. This one's on the left, this one's on the right. So they're alternate exterior angles, so that would be the first thing that you will do. You will then say alternate exterior angles. This will be worth points because you're asked to describe the relationship. Right here, I'll then solve it over here. So alternate exterior angles are equal. So we set these equal to each other. All right, now we need to look and say, well, here we have an x squared, something that we learned earlier in the year. That means that this is a quadratic. So we need to set it equal to 0. And since here our x squared is greater, we are going to move these to the opposite side. So we will subtract the x squared and add the x. So we will get x squared plus x minus 12 is equal to 0. And now you can solve this any of the ways that we learned. We learned quadratic formula, we learned completing the square, and we learned factoring. I wouldn't do completing the square here since this is an odd number. If you prefer quadratic formula, by all means, I'm going to do factoring. So we will multiply our first and our third, so we get negative 12, and we drop the b to the top. what multiplies a negative 12 and has a difference of 1? So that's 4 and 3. But since it multiplies a negative 12, one of these has to be negative. Since this is positive 1, the 4 is positive, the 3 is negative. We divide each one by the number in front of our x squared, so by 1. And we use our song, started from the bottom, and now we're here. So it will be x plus 4 times x minus 3 is equal to 0. So remember, if two numbers multiply and equal to 0, that means one of them has to be equal to 0. So x plus 4 is equal to 0, or x minus 3 is equal to 0. So x is equal to negative 4, or x is equal to 3. So since x makes up our angle and is not the angle itself, x can be negative. But what you do need to do is when you get a negative variable or when you get a positive, you do need to plug these back in just to make sure that it doesn't give you a solution that is not valid. So an erroneous solution. All right, so then we will substitute them in. Negative 4 squared minus negative 4. So that will then give you 16 plus 4, which is equal to 20. So we need to see, does this equal to 2 times negative 4 squared minus 12? Well, negative 4 squared is 16 times 2 is 32 minus 12 does equal 20. So we know it works for negative 4. We plug into 3, does 3 squared minus 3, which is then going to be 9 minus 3, which is 6. Does that equal to 2 times 3 squared minus 12? 3 squared is 9 times 2 is 18 minus 12 is equal to 6. So this one works as well. So both work, so both are a solution. If you plug it in and then your angle is negative, then you will reject it. Or if you plug it in for some reason it doesn't give you the same answer both times, then you made a mistake somewhere. All right, so the directions for number 6 say solve for all missing sides and angles. So in this case, we have a right triangle with 2 of the 3 sides given. So we can use Pythagorean theorem then to solve for the missing side, our hypotenuse. So then we will say 11 squared is 121 plus 36 is equal to our 8 squared. So 8 squared is then equal to 157. Take the square root of each side. H is equal to plus or minus square root of 157. The directions will say round your sides to the second decimal place and your angles to one decimal place. So we will reject the negative. And then we will say that AC, that's our hypotenuse, AC is equal to the square root of 157, which is going to be 12.53 because I'm telling you to round to the second decimal place. All right, so we know this is now 12.53. Let me erase this work to the right now. All right, now we need to go ahead and solve for our angle. So any one, I'm going to just pick angle A. So to solve for angle A, we now need to go and use our SOHCAHTOA. So to use our SOHCAHTOA, our first step is to identify from the angle we pick all of the names of the sides. Well, this 12.53 is always our hypotenuse because it's opposite of our 90 degrees. The angle that does, or the side that does not touch our angle is our opposite, and then the other side that creates our angle that is not our hypotenuse, so this side here, that is our adjacent. All right, so now we will go ahead. We will not use our hypotenuse because this was our rounded answer, so I want you to get in the habit of using the sides that we know that are exact. So we will use these two sides, our opposite and our adjacent. Well, the trigonometry that uses both opposite and adjacent is our tangent. So we will then say tangent of angle A is equal to our opposite 6 over our adjacent 11. And remember, to get rid of this tangent of angle A and to isolate our angle, we need to take its inverse. So we will then take the tangent inverse of both sides. So tangent inverse of both sides. So when we take our tangent inverse, it will undo the tangent ratio that's being done to our angle, and it isolates it. And then our tangent inverse of 6 over 11 will give us our angle of 28.6. So that means the measurement of angle A is equal to 28.6 degrees. So we will then say measurement of angle A is equal to 28.6 degrees. So rather than going through all this work to solve for angle C, we know that when this is a right angle, the other two angles will need to add to 90 degrees. So I can then do 90 minus 28.6 to just solve for the measurement of angle C. So I don't need to go through and do that much work. So the measurement of angle C is then going to be equal to 61.4 degrees. Right, so you do not have to do your trig ratio for the other one. You can just solve by saying, well, I know these two have to add to 90. So if this is 28.6, the other one has to be 61.4. All right, moving on to the next question. All Right, same thing, we're asked to solve for all missing sides and angles. So right away, I can solve for the measurement of angle O very quickly. The measurement of angle O, I know has to add up to 90 degrees since this is a right angle with measure of angle M. So 90 minus 35 will give me the measurement of my angle O, which is then going to give me 55 degrees. So I know this is 55 degrees, right? So it's very easy to solve for the measurement of this angle here. And now to solve for the side, we only have one of them, so we can't do Pythagorean theorem. It's not a special right triangle, so we have to use our trigonometry. So we have to do our SOHCAHTOA. All right, so now we will then go ahead and pick an angle, any one you want. I'm just picking angle M because it's the one that was given to us. And fill in our sides from this point forward. So this will then be opposite. This will then be our hypotenuse. And this will then be our adjacent. Decide which one you want to solve for first. So I will go ahead and I'm just going to solve for my adjacent first. So if I'm solving for my adjacent, I'm giving my opposite, that means I'm going to use tangent. So I will then say tangent of 35 is then equal to our opposite 10 over our adjacent, which is what we're solving for. Right now, anytime that we have our variable that we're solving for in our denominator, remember I told you can switch it with your trigonometry. I showed you why. I showed you how it works algebraically. But we will then get A is equal to 10 over tangent of 35. And this will then give us approximately 14.3 because you're rounding 14.28 because you're rounding to the second decimal place. I know the answer key I gave you to 1. I made that before I decided I wanted to change the directions. Or maybe I just didn't follow the directions for this one because I was trying to get through it really quick. But then that means our A is approximately 14.28. So we will then say that segment MN is equal to 14.28. So this is 14.28. So now the last one that we need to solve for is our hypotenuse. So let me just erase this work over here so that we have room to do it. All right, so if we're solving for our hypotenuse, we then need to identify our opposite and our hypotenuse. We're not going to use the adjacent because that is not the exact value. We rounded it, so I want you to use the exact value, so opposite and hypotenuse. So that is our SO. So that means its sine of our angle, 35, is equal to our opposite, 10, over our hypotenuse. Same thing. If your variable is in your denominator, you can just change it with your trig. So then we will get H is equal to 10 over sine of 35, which when we plug this into our calculator, we will then get 17.43. So our H is then equal to 17.43. All right, so now we know that MO is equal to 17.43. So we solved for every angle and every single side that was missing. Once you did solve for this second side here, you could just use Pythagorean theorem and rounding it to the second decimal place, you should be fine for when you're getting your answer for MO. But you can do it any of the ways that you want. All right, moving on to the next.